So how do dependent samples t-tests work? They're different from independent samples t-tests in our approach to them overall. They're almost kind of an inverse in some ways. In the independent samples t-test, we are comparing the means of each of our two samples, right? So we take a sample and we look at the mean of that sample. Then we'll take another sample, we look at the mean of that sample, and we look at the difference between those two means. And we say if the difference is large enough, then those two samples, if the difference between those two means is large enough, then those two samples come from different populations, right? And they are significantly different from one another. In the dependent samples t-test, we now look at the difference between individual scores, right? So a participant's score at time 1 and their score at time 2, and we look at the difference between there. And then we look at the mean difference in scores, right? So it's a little nuanced difference there. We're not looking at the difference between the mean of each group. We're looking at the mean of the differences among all of the people, right? Look, we can actually use a sampling distribution of the mean difference scores. It acts very similarly to, thanks to the central limit theorem, very similarly to the sampling distribution of the mean. The sampling distribution of the mean difference scores has a mean and a variance that make it normal. Now, what we try to determine is if the mean of this distribution is 0, right? And so, again, we're looking at the difference scores, right? So the difference of each person, we take their score at time 2 minus their score at time 1, that's a difference. We calculate that for each person, and now we're looking at the average of all of those differences. If the average difference is 0, right, and so the mean change is 0, then we would say, well, nothing happened, right? And so that's what we're looking at, is that mean difference. If the mean of those differences, right, the mean difference is 0, well, then there are no differences. And if the mean difference is huge, then we say, well, there is a difference. And then the question is how much change, how much difference really matters? How far away from 0 is too far? Well, that's why we do our t-test. So to calculate t in this case, we calculate all of the difference scores, right? So we take, for each participant has their own difference score, and this is their, I don't know why it says x minus 7, it should be x minus their previous x, right? So x time 1 minus x times 0, or x time 2, x2 minus x1, right? So for each person, it's their difference between what they did on the second verse versus the first verse. Or if we're looking at paired samples, right? So we're looking at husband and wife pairs. We compare, what's the difference between the husband score and the wife's score? And we subtract one from the other. And that gives us then what we call a difference score. Then we take all of those difference score and we calculate the mean difference score, the mean difference and the standard deviation of these scores. T then is going to be the mean difference score divided by the standard deviation of the sampling distribution of the difference scores. What we can look at then, that formula that you see there is that average D, right? So that D with the bar over it is the average difference score, the mean difference score, minus 0, so we don't need to worry about that too much, divided by the sampling distribution of the difference scores, or the standard deviation of the sampling distribution of the difference scores, which is given to us by the standard deviation of the differences divided by the square root of n, just as did before. And because that provides us our margin of difference, right? That's our standard error, the standard error of the difference scores. And our degrees of freedom for this t-test is just going to be n minus 1. So again, this is also a difference between this and the independent samples t-test, where the degrees of freedom was n minus 2. Here it is n minus 1. So then we just do it as we do any other t-test. We calculate this t, or the computer calculates t for us, and we determine if those mean differences are more than what we would expect based on the standard error. And that tells us then if we're too extreme, if t is very high, if it's too extreme or more than will be supported by the distribution of t in this case, given those degrees of freedom, then we would say that any difference we're seeing is real and not just due to chance alone. And that, just like every other t-test, that is ultimately what we're trying to figure out. Is the difference that we're seeing real, or is it due to chance alone? Again, the biggest difference here with the dependent is, instead of looking at the difference of means in two samples, we're looking at the mean of the differences of individual scores between those two samples.